DFG Science TV, a polar climate archive. Drilling in the Arctic, climate research for the future.
At last, many weeks after the researchers returned from Lake Elgegitgin, the cores have also arrived in Cologne. The team unloads the lorry in brilliant sunshine and high temperatures, while the cores are stored in a climatized container at a constant 4 degrees Celsius. The American project manager Julie Brigham-Gret has come to Germany specially for the occasion. She plans the next steps together with Martin Mellis and Volker Wenrich.
Now that the cores are here in Cologne, we are making the final decisions on how the cores will be subdivided.
A total of 512 meters of drilled sedimentary, impactite and consolidated rock cores will be researched during the next 2 years. The aim is to jointly publish the results. The material will then be accessible to the public, the scientists have agreed. Time is tight. The international project partners pressure the team to provide samples.
And so we're finally having now a stack of documents with the requests from our science team. We're identifying the overlaps between different scientists where we have to make some tough decisions on, well, this person gets the samples but this person doesn't. Or we also can identify areas where there could be research teamwork done so that two groups who want to do similar things can actually share in the scientific goals of the project.
The XRF core scanner is located in the Cologne geologists' laboratory, a privilege for the scientists deciphering the Siberian Climate Archive. Only 17 of these instruments exist worldwide. Volker Wenrich will analyze the Lake Elgegitgin sediments during the coming months. He'll focus on measuring what is known as the X-ray fluorescence. He will carry out his investigations on the previously unsampled core. Wafer-thin layers are first scraped from the surface of the core. These may already be oxidized due to contact with oxygen. The scanner then makes a color image. In this way, the scientists have a precise image of the structures and colors of the freshly opened core for future reference. It's important to measure as precisely as possible to make subsequent correlation easier. The core is covered in an ultra-thin film. It's important that no air bubbles form. This could negatively impact future measurements. Okay, these are the results we get for a measured meter. We have a variety of parameters. We generally measure two different things using the scanner. On the one hand, we measure the true element distribution, seen on this graph for example. Here are two elements, aluminium and iron. The iron is blue and the aluminium is red, and we see that these graphs behave very differently. This is really what we would expect. That is, we're dealing here with a resolution of 0.2 millimeters, and this range allows us to really resolve variations in the annual or decades range. High resolutions like this are only possible using technology such as the XRF core scanner.
Das erlaubt eigentlich nur so eine Technik wie dieser ITRAX-Scanner, da so hochauflösend herangehen zu können.
The measurements to record a meter at this resolution on the XRF core scanner take 1.5 days. The researchers need to make haste to evaluate the results in time. Additional information is provided by X-raying the core.
Das heißt, man sieht hier zum einen,
that is, we see here on the one hand that these cracks, etc. actually fit quite well. That is, that this is actually one-to-one, the same section. But one also sees much more clearly the structures in the sediments, which don't always appear in the normal photo, because we only really see the surface there. And on this X-ray film, we actually penetrate through the core and can see structures that are not really seen in color. Okay, in this area there are variations in the brown coloring, and here we see that these are really fine variations, recognizable in the X-ray image. What other exciting investigation methods will be employed to decipher the Lake Elgegitgin archive? Find out next time.
Visit DFG Science TV for more information. Awaken the researcher within you.